Okay, so here we're dealing with an exponential graph. They give us an equation. The equation of the graph fx is equal to 2 times b to the power x plus 1 plus q. They say the graph of f passes through points A and B. They give us the coordinates of A. For B, the y coordinate we don't know yet. And then the line y is equal to 2 is an asymptote of f over there. First question, show that the equation of f is if x is equal to 2 times 3 to the power x plus 1 plus 2. Now, this q at the back, this positive 2, that's easy to determine because we can see the asymptote is 2, so that means the graph was shifted 2 units up, and that would affect q. No? So q is equal to 2, graph is shifted 2 units from, that would be 2 units upwards, 2 units up from x-axis. Okay, right. But we still need to find b. So we've got this so far. Bx plus 1. I know now that q is 2. So I can go and substitute the coordinates of a into that equation, which is 1 and 20. So y would be 20, b x is 1 plus 2, the q is 2. Okay, I'm going to bring over that 2, that would make that 18 on the side, 2b squared divided by 2, 18 divided by 2 is 9, equal to b squared, and then I need to square root, so that will give me b is equal to 3, and there I have my equation. So 2 times, I found that b was 3 and q was 2. Okay, right. 6.2. Calculate the y coordinate of the point B. Okay, so seeing that I have the equation, I have my equation here for the exponential graph, and I know what the x coordinate is. So I can just substitute that x coordinate into my equation and then find the corresponding y value. So I'm going to substitute x is equal to -1. So y is equal to 2 times 3 to the power of -1 plus 1 plus 2. So that will be 0, and anything to the power of 0 is 1. So it will be 2 times 1, which stays 2, plus that 2 at the back. So y is equal to 4. So the corresponding y value there is 4. Okay, 6.3. Determine the average gradient of the curve between points A and B. That's easy. We just use the gradient formula. Find the gradient between the 2 points A and B. So that would be 20 minus 4 over 1 minus the -1. So that's 16 over 2. Gradient is 8. Okay. Right. 6.4. A new function is obtained when f is reflected about the asymptote. Determine the equation of h. Okay, so that means just that this equation is now reflected about this one. So it's going to look something, I'm not going to draw it on the page, but to show, it's going to go down like that. Yeah? So all that is going to happen is basically that 2 is going to become negative. Yeah? Because that q at the back won't change, né? Because it's still, the asymptote there on top is still 2. So my answer, 6.4, is hx is equal to negative 2 times 3 to the power x plus 1 plus 2. Okay, last question of paper 1. 6.5. Write down the range of h. So, again, if the graph is going down like that, what is the range? So it's going to continue going down, nah? But it's going to tend towards y is equal to 2. So it's not going to cross over there. So it's just going to, the maximum is at 2, but it will never touch at 2. So we can say the y is everything less than 2. That's our range. I say, thank you.